Okay, this is part B, which is the green handout, and it's the mountain pass. So I'm going to select that. Okay, over here at the side, I took and wrote down the formulas that are showing up on the green worksheet. Some of those are hard to read, and I made a couple of other changes. Instead of using X in this first formula, here, I use D for distance. That's because these X's here are actually the positions you see over here. They're actually the position vectors in the horizontal X and Y. But over here, this D stands for the range that we're going to go. That's the range here, this range, and it's the distance that we're going to shoot this projectile. So this makes all these D's be the same thing. Also over here, notice that G has to be negative 9.81. You may use something else in physics, that's fine, but this program is not going to give you the right answer if you don't use negative 9.81 on every problem. Notice also that this is negative, and every time you have G up here, they're negative. So what happens is this negative and that negative. That's right, they just cancel out each time. So just keep that in mind. These should all be positives by the time you put that in. Also, be sure your calculator is in degrees before you get started, or you're going to get these answers wrong. So, we're going to look at our problem here. And here, they're looking for the range and the initial velocity. So that's two different problems we're going to work out. Well, range is this first problem here, which is just the distance formula. It's the first equation over there. So I'm going to pause and I'm going to fill that in. And what I got on my calculator is 94.393. I need to round this off to the hundredths, so this is going to be just 39. Now I'm going to use this range and this firing angle in one of these equations over here to find the initial velocity. Well, which one over there on the side has velocity initial? That's right, that's this third one here. So it's got the square root GD over sine 2 theta. So I'm going to take and plug in range for D, 9.81 for G, and this angle for my theta that's over there. I'm going to pause so I can do that. So on my calculator I got 31.56. On each one of these problems, remember the white instructions say you need to write down the formula you have over here, you need to plug in the appropriate numbers, and you need to show all your work in your notebook. You'll be required to show that work as when you turn in your problem to show that you got it right. This problem now asks us to find the range and the firing angle. Notice over here that's going to be the first formula for the distance again, and then it's going to also ask us to find the firing angle, which is this problem here. But this equation here finds 2 theta, and in order to find just theta, we need to divide by 2. When I do plug in this y here into my distance formula over there, what's going to happen when I do 0 minus negative 115? I get negative 115, but when I square it, what happens? That's right, it's going to become positive. So be sure that you are doing a positive here plus a positive once you squared these. And I got 145.62, and then I need to find the firing angle. That's the fourth equation down here that says 2 theta. So again, I'm going to plug in negative 9.81 for G. This is my distance I'm going to use, and here's my initial velocity that's going to go on the bottom. Notice that on the bottom that has to be squared. Also notice that this one here is inverse sine, so you need to use your inverse sine key. And when you plug it in, you get the answer of 2 theta. So what do I have to do once I plug it into this formula? That's right, I need to divide that number by 2 to get just the angle theta. And what I got on this one is 39.968, so that's 97.